So 9.2.2 is just going to cover regular polygons. Yesterday we covered circles as well, both doing their circumference and their area. Today we're just going to narrow our focus and look at regular polygons. And the formula that we used was area equals 1/2, and then we had that new fancy word we learned yesterday. Who remembers that fancy word? Apothem, right? The apothem times the perimeter. Okay, and the perimeter is going to change for each polygon depending on how many sides it has. So let's start with a heptagon. So we're going to find the area of a heptagon. And that heptagon is regular. And I'll explain why that's important in a minute. And it's going to have a side length, of 2 feet. And we want our answer to the nearest hundredth. Sorry, no, tenth. To the nearest tenth. Okay? So the 1/2 the apothem times the perimeter formula works for regular polygons. Regular just means it's going to have all the sides are the same length and all of the angles have the same measure. If for some reason you're given a figure and it has different measurements on each of the side lengths, the 1/2 the apothem times the perimeter isn't going to work, and you're going to have to break it down into rectangles and triangles and then add them all together. You probably won't see any of those in here. Okay? So we're looking at a heptagon. All right, so in the first step for finding the area of any figure, you need to first identify the figure. So it's written in the question that it is a heptagon. Second thing you want to do is you want to write down the formula. So it's going to be area is going to be equal to 1/2 the apothem times the perimeter. But let's draw a heptagon. Heptagons are pretty hard to draw. Why? Anybody know how many sides a heptagon has? 7. Has 7 sides, which makes it pretty tricky to draw, especially the fact that it's regular. So when you're drawing it, you're supposed to be getting it as close to all the same side measurements as possible. Makes it really hard. So that's as good as I can get. Good luck. But that's a 7-sided figure. This one's a little bit longer, but it's not supposed to be. Anyway, that's what a heptagon looks like. And one of its sides has a length of 2 feet. So from here to here is 2 feet. That means all of them are 2 feet. 2 feet, 2 feet, 2 feet. All 7 sides. Okay? So if we have the formula 1/2 the apothem times the perimeter, we need to plug in the apothem and we need to plug in the perimeter. What are we missing? What are we missing? The apothem. They didn't give us the apothem. They did give us one of the side measurements of 2, so we can get the perimeter, right? So we know one of them's 2, and there are a total of how many sides on a heptagon? 7. That means that the perimeter is what? 14. So we've got 14, but we need to find the apothem. Okay? So if you remember from yesterday, the apothem goes from the center to one of the sides. We'll put a little letter A there. And so we need to get that apothem. All right, so what we're going to do is we're going to create a little triangle inside of that heptagon, and then we're going to pull it to the outside of the heptagon. Okay? Where it comes out and it makes that right triangle right there. If this side of the heptagon is 2 feet, then this side of the heptagon is 2 feet, and this height is going to come straight down and be our apothem. and that's going to be half of it. So half of 2 is just 1. So that's 1 foot right there. Okay. We're going to be able to get the length of that apothem by using something we learned last chapter called inverse trig. Okay. So we're going to use, actually we're going to use regular trig. We need to get this angle right here. Okay. The way to do it is to realize that, okay, we have a full circle right here. Circles have how many degrees? 360 degrees. And we can divide this into 7 sides. So if we take 360 and divide it by 7, we get roughly 51.4. You simply do that on your calculator. You type 360, divide it by 7. You get this decimal, I rounded it to 51.4. And then we divide that by 2 because we split that triangle in half right there, which gets us to, divided by 2, 25.7 degrees. Okay, so this angle right here is 25.7 degrees. All right. So from that angle, we have this side over here, which is the opposite. And we want the apothem, which is the adjacent. And so we figure out which of the 3 trig functions we're going to use. Sine, cosine, or tangent. Which of those 3 uses opposite and adjacent? That would be the tangent. And we're going to say the tangent of 25.7 degrees is equal to the opposite, which we have a number there, which is 1, over the A. And we're going to be able to figure out how long that A is, which is what we need to plug into our formula right there. So we're going to multiply both sides by A to get that out of the denominator there. They cancel over here. And then we're going to divide both sides by the tangent of 25.7. And they cancel over here, so we have A is equal to 1 over the tangent of 25.7. So we're going to clear out our calculator. We need to make sure it's in degree mode, so it should have that little DEG. And then we're going to type 1 divided by the tangent of 25.7. Hit the equal sign. And I got, oops, oh yeah, I got it. That it is approximately 2 point, and I'm going to round to the nearest tenth. So if I have a 0 and there's a 7 next to it, rounds up to a 1. That little apothem right there is roughly 2.1. Okay, so that's what fills in here for our apothem. So then we just type that into the calculator. Remember yesterday I showed you there's 2 ways to do it. You can either take 0.5 and multiply it by each of those, or multiply those together first and then divide by 2. It's up to you. So I'm going to do 0.5 times 2.1 times 14. Hit the equal sign. And I get 14.7. And then the last step is just to attach the units. So this one was in feet. So I'm going to say feet squared. All right. Any questions on example number 1? All right, these are a little bit tricky, so let's do another one together. Example number 2. This time we're going to have a dodecagon. It's going to have a side length of 5 centimeters. It's regular. It's always good to know. And we're going to round to the nearest tenth again. Okay. Dodecagon, side of 5 centimeters, and we're going to round to the nearest tenth. Dodecagon has how many sides? Anybody know that one? How many? Well, decagon is 10, but when you stick the do in front of it, it makes it 12. So it has 12 sides. And so if you want to draw it, you can try, but it's really hard for me to even draw it. So I'm just going to pull out the triangle, And know that if it was a full side that was 5 centimeters, half of that is going to make this how many centimeters? 2.5 centimeters. Okay? We're going to need to get that apothem for sure. And we need this angle right here. To get that angle, I'm going to take the 360 that should be in the full circle in the middle, divide it by the number of sides, which was 12. This one comes out to a nice even number because 360 divided by 12 is 30. And then we need to just half it, so it's 15. So 15 degrees right here. And we're going to take that and use it to get that apothem. So from that angle, we've got the opposite and adjacent, which we know is tangent. So we're going to say the tangent of 15 degrees is equal to the opposite of 2.5 over the adjacent. You can use the variable a like I am, or you can choose x if you want, whichever is more convenient for you. But you're basically going to solve it the same way we did in example number 1. You're going to multiply both sides by a. You're going to divide both sides by the tangent of 15. And type it in your calculator just the same way. The a's cancel over here. Tangents of 15 cancel over here. So all you need to type into your calculator is 2.5 divided by the tangent of 15. So let me show you how to do that. Obviously, make sure it's in degree mode. Type in 2.5, divide that by the tangent of 15, hit the equal sign. And so that apothem is going to be 9.3. Okay, so I'm just going to write it over here because that'll help me when I go to plug it into the formula. Okay, so the formula for a polygon is 1/2 the apothem, which we know is 9.3. Oops. Area equals 1/2 the apothem times the perimeter. The apothem is 9.3. The perimeter we need to get. Sorry, I haven't done that yet. One side was 5, and there's a total of 12 sides, right? So we're going to do 5 times 12. So what's the perimeter? 60. Getting the 60 is easy after spending all that time getting the apothem. Thank you. And so we're going to punch that in the calculator. I'm going to do 0.5. Oh, can't see it. Shrink it just a little. 0.5 times 9.3 times 60. I got 279. 279. And this one is in centimeters squared.